on top of returning the paper, exam paper, I'm also distributing one-page double-sided printout to you. Okay, so make sure you pick up one. Okay. I brought definitely more than enough for this classroom here today. They might be somewhere in the back if you don't have one. Okay. Okay, so let's continue on the second order ODE, non-homogeneous case with constant coefficients. In previous lecture, I started. Okay. We basically introduced this theorem. The theorem says if you want to find the general solution for the second order ODE, okay, and the ODE basically is in the general expression, for example, like this. Non-homogeneous case. What you need to do is you need to find two solutions. One is called YH. YH is the general solution to the homogeneous second order ODE. So get rid of the FT, let it equal to 0, then you get the homogeneous one. And the YH is the general solution of the homogeneous one, which we have learned. YP is the particular solution to this. So YP is a particular solution. So the focus here is to find the YP, because once we find the YP, then we'll be able to find the general solution for this one. Okay? Yeah. And I said we're going to use two different approaches. One is called method of undetermined coefficients, and this is what we're going to do today. And after this, we have another approach called variation parameters. Okay, so let's look at this one here today. So, what's method of undetermined coefficients? First of all, this method is for the constant coefficients. Okay, so basically, we're talking about ay double prime plus by prime plus cy equal to f of t. So we're talking about a general formats like this. Okay. A, B, C at here are constant coefficients. Okay, so what do we do then, right? Here's a key idea. The idea is essentially, if we know what the f of t is this input to the system. Which you have it if you have the ODE given at here, right? Then what we want is we want to say, let's say for example, if f of t, right? If f of t equal to e to the power of a negative t, for example, okay, or f of t equal to sine t, right? So that's just an example here. Then maybe, right? We can guess. So, sorry, can we quiet down here? Yeah. So maybe we can guess is if you have input is exponential type of function, or your input is a sinusoidal type of function, and you give it to the system, then the system maybe, just maybe, right? And actually, it's not just maybe. It turned out to be the case. Then the system will probably spit out an output in a similar format as the input function. Right, so that's the idea. So if you give a sinusoidal to the system probably will give back a sinusoidal type of response. Right? So that's what we call, for the YP, the particular solution, we guess. So we guess it. How do we guess it? We guess it based on the type of input to the system. So we call it lucky. Sometimes this method is also called lucky guess method. So you based on your input, then you give not a really lucky guess. You give a reasonable guess, right? So how do we guess then, right? This is basically the handout I gave it to you. you guess based on this table here. So if you look at this table, when input is exponential 1, then you pick your choice yp, which is your guess, as a c times e to the power alpha t. So you still keeping this. You're keeping this e to the power alpha t at here, okay? But you change this k to another c, okay? And of course, we need to find the c, okay? If your input is a t to the power n type of input, then you guess it as first t to the power n, but you actually contain all the lower power terms. Okay, that's your guess. If your input is sinusoidal, and your output should be guessed also a sinusoidal, but then you consider both cosine and sine at the same time, and with n and m, which are the constant, we're going to try to find it out. So you see the similarity to the guessing here, right? You're guessing your fp, y of p, particular solution, okay, based on the type of inputs at here. But one thing is very strict. You get to use this format strictly. For example, if your input is cosine omega t, okay? So you cannot just pick a guess, say, okay, my input is going to be my yp going to be n times cosine omega t. That's not enough. Your guess has to be n cosine omega t plus m sine omega t. Okay? M could be 0, but that's a different story. So your initial guess has to be exactly in this format at here. Okay? Yeah. That's called a lucky guess method. And this case here has a combination of exponential and sine, cosine as input. So your guess should also have a combination of exponential, sine, and cosine. Okay? Yeah. So that's our guideline here for this table to find this particular solution. And this is basically the idea of a method of undetermined coefficients. Okay? Yeah. So I'll just write down a little bit summary here. So method of undetermined coefficients, okay, is based on the type of input, the type of function for f of t. Okay, so f of t is the input. What type of the function f of t is, then we pick our guess. Okay. But you do have, okay, a few rules. Okay. First of all, the basic rule. Okay. This basic rule is exactly what I just said. It's the table, right? A table in lecture notes on page 3. Okay. Use this table in the lecture notes. Okay. That's the basic rule for yp. This is all for the particular solution yp. Now there are two other rules. I don't think I'm going to go into the details of it here. Okay, I will show you the other two rules when we have an example to give you a better understanding of the other rule. But the other two rules, one is called the modification rule. Okay, so the basic rule sometimes doesn't work. So we had to modify our initial guess. Okay, so this basic rule is strictly out of the table, right? So sometimes we had to modify it slightly, and this is called the modification rule. And I'll show you the situation when do we modify the basic rule. Okay. Yeah. And the third rule is called the summation rule. Okay, the sum rule. This one is actually not too bad to understand, and that's actually the back of the handout. Okay, the other side of handout. So take a look at the type of input to the system. Right? This is a type of system input f of t. Some of them, right, it's not just one single type. You know, this is fine, this is just constant. And that's also fine, that's just an exponential function, right, t to the power 2. And same thing, this is also fine. And this is all good, just one single type. But then here has a combination of exponential and a t function. And same thing like this one here, you have a combination of exponential and a sinusoidal, right? Then in this case, you need to modify the rule, which we call it sum rule, right? Like this one here, 60 squared sine phi t. So you have the format, right, from the previous table times the cosine, another format times the sine. So you have to modify this, but that's not, we call it sum rule here, okay? We call it sum rule. So that's this table here. This is much more for maybe much more complicated situations, right? So if f of t is really complicated input, then you look at your f of t and look at the f of t, which cases does it fall into in the first column, and then you pick your yp, the former yp from the second column at here. Okay? That's called the sum rule, okay? Which I'll show you in examples later. Okay? So essentially there are three different rules to guide us in terms of the choice of yp, okay, from the beginning. Okay. So for this portion, my experience is you need to experience basically different type of examples, and then you'll get more comfortable with with using it. Okay. Yeah. So let me show you a few examples. Okay, I'll show you different examples here. So let's say we want to solve this second order ODE with constant coefficients, and input is not zero, 8t squared. Yeah. First step, and obtain the general solution for y prime plus 4y equal to 0. Okay. So we call it YH, right? So that's the general solution for the homogeneous second order ODE. Okay, the homogeneous portion of the original one. And we have learned this. So how do you solve? You basically form a characteristic equation, okay, from this second order ODE. Solve for lambda. And you get two complex conjugate roots. Basically alpha equal to 0 and then beta equal to 2. And you have the handout from previous lecture, so your YH is basically just C1 cosine 2t plus C2 sine 2t. Okay, so that's the first step to get the YH. And second step is obtain the particular solution yp. Okay, so this yp is the particular solution for this non-homogeneous one. Okay, basically whatever we're looking at. Okay, so this is the moment that you will actually look at the handout that you have. So you look at this is your f of t here, right? So input is f of t equal to 8t squared, 8t squared, yeah, 8t squared. Okay, 8t squared. I'm going to go to my table over here. Okay. Where's 8t squared? It's this general format. N at here equal to 2, and small k is 8. Actually, doesn't matter. So your choice of particular solution yp needs to be kn, n is 2, so k2t to the power 2, k1t to the power 1, then plus k naught t to the power 0, which is 1, so plus k naught. Okay, so your choice of yp, so from the table, okay, yp is in the form of the following: yp equal to k2 t2 k1 t and k naught. So that's the guess part, right? That's the guess. And of course we need to find out what k naught, k1 and k2s are. Okay, so the exact value of this. Otherwise you wouldn't call it particular, right? Particular solution means you have all the specific information of the function. You don't have any unknown parts in the function. It has to be, everything is known. So how do I find the three constants, right? So what do we do is we will take derivative. So first take first order derivative of yp. So that gives us 2 k2t plus k1. Then you take another derivative, okay, of the yp, and you get 2k2. Okay. So basically you have yp prime, and then yp double prime. Okay, you got the three derivatives. The reason we're doing this is because yp is the particular solution you're looking for. And what does the particular solution mean? It means if you substitute the yt back into the second order non-homogeneous ODE, it should satisfy the original second order ODE, right? That's the point. So we sub yp prime and yp double prime, okay, into the original second order ODE, y double prime plus 4y equal to at squared. Okay, sub it back into the original ODE. So let's take a look at what happens if we do the substitution back into here. Okay, so yp double prime is 2k2, so this term is basically 2k2 here. So 2k2, there's no yp prime, that's good. So there's only 4y, so 4 times the yp, so 4 times k2t squared, k1t, k naught, and then equal to at squared. And that's a substitution. Now at this stage it seems to be pretty messy. How am I able to get a solution for all the three constants, right? So, and in the next step what you do is you clean it up. You group all the similar power terms together. So for example, there's only one t to the power 2 term. So that's 4k2 t squared. And you put it down here. And then for the t term, you also only have one. That's 4k1 times t. For constant term, you do have 2 at here. Okay, so you get these two, put them together. And then total equal to at squared. Okay. Now from here, right, remember you're trying to find a solution for k naught, k1, k2. So the solution at here should give you 8t squared. Yes? Yes, 4 k naughts. Excellent, thank you. Good. So the solution to give you 8t squared. So this is a very common approach, as you probably will see in later some other class. To solve this, basically you compare coefficients. So we get this so-called comparing coefficients, okay, of both sides, okay, of both sides of the equation. Compare coefficients. This side, the t squared, has a coefficient of 8. So this side has 4k2. So that should equal to 8. And this side has a 0, right, for the t term. So you should have 4k1 equal to 0. And similarly, you have a 0 constant on the right side. So that 2k2 plus 4k naught, that should be 0 too. So this time you have 3 equations now, then you'll be able to solve for all 3 constants. K2 equal to 2, K naught equal to 0, and then K naught equal to what? So 2 times 2, 4, K naught equal to -1. Okay. This comparing coefficient is a very useful approach. I think when we learn Laplace transform, we'll use this comparing coefficients again. Okay. So therefore, your particular solution yp equal to 2t squared minus 1. Now if you're not too sure, if you want to verify, you can always substitute this yp back into the original ODE to make sure it is a solution. Right? So finally, then you summarize the general solution for this non-homogeneous ODE is YH plus YP, and that gives you C1 cosine 2t plus C2 sine 2t and 2t squared and minus 1. Okay. Okay. Let me show you another example. Okay. Yeah, this is all about different cases. Okay, once you get comfortable with the different cases, then you will be fine. Okay. So let's take a look at this example here. So y double prime minus 3y prime plus 2y equal to e to the power of t. Okay. Okay, for this one here, I will focus on finding this yp, okay, but I still need to do the step 1. Okay. Step 1 is to find the YH. So YH here, lambda squared minus 3 lambda plus 2 equal to 0 is the characteristic equation of the homogeneous one. Then you get lambda minus 1 lambda plus 2. So lambda equal to 1, lambda equal to -2 are the 2 real distinct solutions. So your YH equal to C1 e to the power of t, C2 e to the power of -2t. Yes? Oh, yes. -2. Excellent. Good. Yeah. Oh, actually, that reminds me, that last lecture at the beginning, I was trying to correct one error a student pointed out, and I double-checked. There's no error. Okay. Whoever pointed out, you tricked me. But so I stand correct for my lecture notes. Okay. Yeah. Good. But this is a different story. This is wrong. Yeah. Step number 2 is to find YP. find the yp. Now this is the part, actually you will notice the modification rule will come in the picture here, okay? What is the input here? So f of t equal to e to the power of t. Okay, this is f of t. Now if I pick my yp based on this table, okay, this is the table here. When your input is this format, your output, not an output, your choice yp should also be in this format. Okay, so f of t, according to the table, yp should be cet. So let's call it cet here. Right? That's the direct initial choice of yp. However, if you look at it carefully, this yp is exactly the same format as what? As that C1e to the power of t, right? So this one here, if you recall that, this essentially is C1 times y1 of t plus C2 times y2 of t. If you remember, in order to find a solution, general solution for the homogeneous one, you need to find two linear independent particular solution, y1, y2, and then you can combine them together to get a general solution, right? So these two are linear independent solution. And this is e to the power t, e to the power 2t. And these two are the so-called the basis of that solution, right? You use the two bases and then you form a general solution. But now, according to the table, you pick your yp as c to the power et, and that exactly is this term, basically. So, assuming you can find a c value, right? Let's say maybe 2. But this term, it basically will be included in this term here, right? So that's nothing particular at all, basically. Okay? So you want this yp to be different from here. That cannot be included in the yh. Okay? So then what do we do then, right? So in this case here, this is basically you have to apply the modification rule now. So essentially, in this case, I will write it down if you were. It happens to be similar or same as a term in YH. Okay, in YH. So in this case, we have to apply the modification rule. So we apply the rule number 2, the modification rule. Okay. To apply modification rule, what you do is you multiply your initial choice with t. You multiply this one with t. Okay, that's how you apply the modification rule. So now your yp equal to c times t, and then e to the power of t times e to the power of t. Timing t is to make sure it is different, linear independent from your original solution of the basis solution in the YH. Okay, yeah. So this is our choice of YP. But there's another situation which I should, if I got the time, I'll show you. You multiply the t, it maybe will be still the same as the other basis. So then what do? Multiply by another t. So until you're completely different from the YH here. So, but not in this example, okay? Not in this example. So this is a YP at here. Then we calculate YP prime, product rule, YP double prime, more product rule, substitute yp prime, yp double prime back into the ODE. So which is ODE? ODE here is y double prime minus 3y prime plus 2y. Okay. So sub into y double prime minus 3y prime plus 2y equal to e to the power t. Okay. Substitute this. So what do we get? Here is your y double prime. So c times 2 et plus t, and this is yp prime. So 3 times c e to the power t plus t e to the power t, and plus 2 times yp, 2ct et, overall equal to e to the power t. A lot of e to the power t and a lot of c, but you can actually simplify greatly by combining all the terms together. You end up with just a negative c e to the power of t equal to e to the power of t. Okay, so you end up with this simple relationship. In order to make it the same, so c has to be -1. So finally, you have your general solution, that is yh plus yp, and that gives you c1 e to the power t, c2 e to the power 2t, then plus yp, and yp is negative t times e to the power of t. Okay. See example here, right? Yeah, this is a modification rule. So you have to modify your initial choice to make it different from the basic solution of the homogeneous equation. Okay? Yeah. So let me quickly go over the next example, just to show you the case, how we need to further modify it. Actually, do I have an example here? Okay, so actually I don't have an example here, sorry. Let me different examples. Try different examples here. Maybe I should come up with an example again next lecture, okay? Okay, let's take a look at this example, okay? This is basically like a little bit the sum rule, the third rule here, okay? Okay, for this one here, the right side, I have two different inputs. One is exponential, and the other is the sinusoidal. Step one is to obtain YH. I'll skip the detail. You can take a look at it. It's very straightforward. Okay, so you have C1 cosine 3t plus C2 sine 3t as the general solution for homogeneous one. Okay. Step 2 is for YP. Okay. For YP, we look at the inputs of the system. And f of t basically is addition of two functions, 5 e to the power t and the 2 times sine 3t. Okay? Yeah. So then my yp, I can guess it, okay, according to the two different inputs at here. Okay? So we can guess the yp as yp1 and yp2. Okay. So yp1 is the one corresponding to 5e to the power t. So you look at the table, you can choose your yp1 as c times e to the power t. And e to the power t is not anything similar to sine, cosine, right, in the original homogeneous solution. So this one you don't need to modify anything at all. But for yp2, this is a sinusoidal input. If I use the table to give the initial guess, yp2 should be a times cosine 3t plus b times sine 3t. Okay? Right, so that's the lucky guess based on the table. But here's the problem now. If you look at your lucky guess at here and compare to your homogeneous general solution, what happens? 3, 3, 3, 3. You all have 3 here. So this yp is not anything particular. It's actually part of this yh, right? So what do? We modify it using the second rule, modification rule. So your yp should actually be a times t, b times t, to make it different from your original. So your yp should be yp1 plus this yp2. And the next step, you calculate yp prime, yp double prime, okay, and then substitute into the original equation to solve for all these unknown constants. And this is the part you have to be extra careful, because now you got so many terms, right? And a lot of product rules, sine, cosine, and then group them together, compare coefficients, solve for constants. And I'll leave that to you to do an exercise. Okay, see if you can successfully. This is probably could be the most complicated, case now, right? To solve for constants. Okay, yeah. And I'll come up with another example, which is the most extreme example. So modification rule, modify once, and then you can modify twice. Okay, in the next lecture. Okay. Any questions? Okay. Okay.